Alrighty then, exciting stuff coming from space weather, including the European Space Agency forecasting an earthly directed CME. We'll show you where it's coming from momentarily. In the meantime, here's a 24-hour video from SDO. And you can see the eruption in there of the Michael Jordan filament, which is now completely gone. Part of it's relocated, part of it has blasted off. Is that the one on the way to Earth? Again, we'll cover it. We've also got about a 50-50 chance of an X-class flare, according to the computerized solar flare forecasts on the NASA site. We'll cover that as well. And it's all because of that sunspot 3723. It's our T-mass, the most active sunspot. Again, massive filament eruptions occurred earlier this morning. And we'll talk all about it here. Here we've included the 193 angstroms 60-minute running difference along with 171 angstroms, great at showing those filamentary eruptions. You'll see one just south of center solar disk and one well out on the east. Also some activity there on the western limb. That's the Michael Jordan solar plasma filament. And thanks for tuning into the Smash News Network, least busted name in news. Congratulations on realizing the channel exists. If you're new, don't forget to press the subscribe button. Otherwise, how will you get the world's most comprehensive daily space weather content and most detailed solar imagery? I don't know how, so press subscribe. And regardless of whether you're new, press like. And also, we would appreciate it if you pressed share, as it helps the video content be seen on social media, of course. Thanks to everybody who's helped promote the channel throughout the 6+ years of making these videos. Today's quote is from Salvatore Dali. "Have no fear of perfection. You'll never reach it." Yeah, be a perfectionist. I encourage it, because you'll never achieve perfection. But if you don't attempt it, you won't even come close, will ya? Moving right along to some space weather stats. Radio flux now at 199 solar flux units. There's the one-year graph from solon.info/solar, solon.info/solar. The black line is the radio flux. So let's see. NOAA is not forecasting any incoming space weather. However, ESA is. So we'll skip NOAA's Enlil spiral and just look at ESA's. And it's because of a CME that erupted today. So ESA is forecasting that to reach Earth in a mild fashion way out on the 29th. I don't. That seems a little bit. Maybe it's an ultra slow moving CME. I guess that's what it is. It certainly doesn't look like a coronal hole high speed stream. It looks like a CME there. So. Yeah, it looks like some kind of really slow-moving, glancing blow. Hey, no arguments here. I think we do know which one they are modeling there. And we'll show you the data so you can make up your own mind. Don't take my word for it. That's why we show the data. Today's Geospace Magnetosphere movie, we're not showing pressure today. We're showing density. So, you can't get bored with things. Otherwise, you'll get burned out on them. So today we're showing pressure. Keep in mind the white is low pressure. I mean, not pressure, density. The white is low density and the dark blue is the highest density. That's the past 4 hours. And next Earth magnetic moment from the ground level. Here's our, we're mixing this up too, showing the polar map this time, the polar map. So those are the most likely place to see the auroras there, where you see those delta B readings showing up there. That's changes to Earth's B field, the field that goes through the magnet. This magnet being planet Earth. KP index at 3, KP3. A little more active conditions here at the moment. And we'll cover some solar wind data next. So there's ACE, which orbits Lagrangian point 1, about 1 million miles from Earth. 3.57. About 3.5 protons per cubic centimeter is the solar wind density there. Solar wind velocity here quite slow at only 340 kilometers a second. At Discover, Similar readings, 4.2 protons per cubic centimeter for density, velocity 339. So not very low solar wind, actually. So our GOES magnetometers here, a bunch of missing data on various instruments starting late last night. So I have no idea what the GOES magnetometers were doing in those missing segments, obviously. That is a 3-day graph of the GOES 16 and GOES 18 magnetometers located in geosynchronous near equatorial orbit at about 23,500 miles of altitude. Here's our heliosphere magnetism, and Earth is in a North Pole magnetic sector. And you can expect to stay in a North Pole magnetic sector for the foreseeable future here, as there's no South Pole sector there showing up in the data until the opposite side of the sun. So expect lots of North Pole-oriented coronal holes and not so many South Pole-oriented coronal holes. Here's our line of sight field plot. And that's basically all of the sun's magnetism in one convenient 4-day model. Showing 3 different fields in the corona and the field of the photosphere. Good times. Here come coronal holes. So as you can see there, mostly North Pole. We see some South Pole ones showing up there and then going away. So right now, North Pole-oriented coronal holes are winning the tug-of-war in the east. It has become more stable than it was since yesterday. Again, North Pole-oriented coronal holes are going to be the thing. Here are coronal holes from SDO, and some of those in the east will become a little bit more well-defined here as they rotate in. So keep in mind the solar corona, the sun's atmosphere is extremely bumpy, and parts of it obscure other parts of it. So if you're looking down a hole of a really bumpy thing, it has to be kind of pointing at you to be able to see it, right? Hopefully that makes sense. And let's move on to sunspots. Sunspots. Now at about 140 sunspots is the current number. So here's our flare probability monitoring scoreboard, and we did get one new named group, I think 3726, and it looks like we have more sunspots rising there also. So about a 50-50 chance of an X-class flare from sunspot 3723. Again, it is our T-mass, and here comes some more SDO images. Well, here's this. There you can see that too. There's a great potential field surface source map of the photosphere, along with the magnetogram and the names of the sunspots. All right, anyway, back to SDO imagery. Well, I mean, that's SDO imagery also, but there's the continuum in its full animated glory. And some degradation of sunspots in the north central portion of the solar disk. Besides that, mostly stable. Correct me if I'm wrong. Maybe you're seeing something I'm not. Looks mostly stable to me. Here's our magnetogram, and we're going to zoom way in and show you sunspot 3723. So that's what a sunspot with about a 1 in 2 chance of producing an X-class flare looks like. The one directly south of the Earth scale there, that's 3723. And I like it. There's a close-up of the magnetic fields. We rotated the field of view here to give that cool effect of it being sort of stationary on the screen. So there you have it. And let's get into energetic particles and flares. We ain't got no energetic particles. We ain't got none, see? We ain't got none. Doggone it. Also a bunch of missing data there in the GOES X-ray flux. But, you know, you can look at the other imagery and say, yeah, there wasn't anything going on. Because it would, you know, show up in other imagery. I don't know what's happened there. Packet loss. I have no idea. But here's our largest flare of the past 24 hours. It was at about 12:40 universal time. We can bring that back briefly here for you. Yeah, about 12:40. There it is. It's just an M1 class event. Not super exciting. So So let's take a look at those. Here we go. There is the SDO. And we've kept the 193 angstroms imagery on there just so you can, that's the 60-minute 193 running difference. And yeah, that is going to show you the filaments as well as active regions and flares. So that's 94 plus 193, 60-minute running difference, 30 frames per second over the past 24 hours. This video was recorded at 4:51 p.m. Eastern Daylight Time. So that's what's going on. And of course, you're probably wondering which one of those filamentary eruptions is the earthly directed one. Our veteran viewers are probably well aware already of which one it's likely to be, and we'll get to that next. But first, a solar system forecast, as people want to know where stuff is before they think about plasma flying through the solar system. So here you go. Here's where things will be on July 2nd. We'll have a crescent waning moon. Here's a star chart for our location, Lehigh Valley, Pennsylvania. You want to create your own, go to skyontelescope.org. Make your own lovely star chart by inputting your city, zip code, etc. It's splentacular. And up there right now, we've got the Sun, Venus, Mercury, also Jupiter and the Pleiades are setting. Next, our astronomy photo of the day. It is the Dark Doodad Nebula. Yeah, the Dark Doodad Nebula. I'm not kidding. Which is interesting. It's a dense molecular cloud. It's largely an absorption feature in these wavelengths. So it is... I'm having a little bit of trouble with my... Turn down my mouse sensitivity here. There we are. It's the Dark Doodad Nebula. And it is adjacent to a really bright, massive, rowdy, high-output blue giant star, which we'll show you here momentarily. It's a very large image, by the way. I actually have it shrunken a little bit. There's a globular cluster. There it is, which is like an elliptical galaxy within a galaxy, and there's that bright blue star as well. The Dark Doodad Nebula, which is the astronomy photo of the day. There's the full image by Rocco Sung. Cheers. Well done. So, CMEs, you're going to see one pop out of the west, and then one kind of pop out of the east. And I don't know, it looks like, if I had to guess, I guess I do have to guess, the one that comes out of the east is the one that ESA thinks has an earthly directed component. That's what I believe is going on here, as that one out of the west is not modeled to hit Earth, and it'll look even more obvious from Stereo A's perspective. So let me bring these back here. So first, this one, a really nice quality bubble there, a proper bubble eruption. And that is the Michael Jordan filament making its way out into space. So some of it collapsed. A tiny bit of it might have relocated, but most of it either collapsed or blasted off to the west and south. So that's the Michael Jordan filament. But then there's a second event that looks like it's mostly out of the east. It may even be partially overlapping this one. Another kind of a stealthy coronal mass ejection. So there's a second one in there that's likely to have an earthly directed component. It looks like it's off to the east, but I think part of it is earthly directed because it originated from right in the center of the solar disk. So here's Stereo A, and you can see Stereo A looks like it's more directly, like the Michael Jordan filament is more directly oriented toward that than Earth. So that's sort of further evidence that that one out of the west isn't likely to hit Earth. However, this other one, I would think, is highly likely to hit Earth. So here are our custom CME maps. So there are really two separate events there. Again, they might be partially overlapping, but you'll be able to see it a lot more clearly when we zoom in here. We've got a couple different steps to zoom as well. A few missing frames there. So here's the 193 angstroms, 60-minute running difference, along with the coronagraph and the SDO 304 angstroms. That'll be very good at showing filaments. And yeah, when that second event pops off, oh man, that is really tough to say. It looks like that second event has a component that's coming right out of this center of the solar disk, and that makes it kind of likely that it has an earthly directed component. You can see a hider flare where that lights up. And keep in mind, CMEs can be very stealthy if they're highly concentrated and sort of headed directly toward the aperture. They can be very deceptive that way. Here we've switched the 193 running difference to regular 193 angstroms. I don't know if that helps you, but if that is earthly directed, it's very slow speed. According to the modeling of ESA, it's probably something like 300 kilometers a second, maybe. So it's it'll be dicey expecting to see any kind of a major space weather storm from that. It's not likely to produce a solar storm. Really, don't expect to see a major increase in the KP index or anything like that from that likely impact. Anyway, next to filaments, and you're going to see the Michael Jordan filament here vanish, because we just watched it blast off from the western limb at Cerro Tololo, Chile. Earlier it was there, and then rapidly it's not there because it's blasted off. So here's the grayscale imagery as well. And I'm not so sure. It looks like those other filaments were intact. I don't see any other motions besides the Michael Jordan filament. So I suspect the rest of those actions were just hider flares that were secondary. I don't think there's any earthly directed component. I have to disagree with ESA on this one. Again, look at the filaments there. You're only going to see one vanish, and that is the Michael Jordan filament. So, I mean, there it is. Oh, okay, there is a second filament down here in the southern hemisphere right there. Let me go back. But part of that's still intact, so yeah, I don't think there's an earthly directed CME, folks. Terribly sorry. And once again, there's one last look at the filaments. Just remember, folks, there is a flare watch still in effect. So, all right, let's do bonus features real quick. The GO 16 SUVi and 304 angstroms. They'll last about 2.5 hours. Charging hazards are next. We have some significant charging hazards there over Southeast Asia, which is low energy electrons are building up on the outside of geosynchronous spacecraft, like the GO 16 and the GO 18, which can cause communications breakdowns. So, not likely to cause any internal errors, just communications failures from some satellites there over Southeast Asia as low energy electrons get on, but not in the spacecraft. So here's our GOES electron flux, kind of low, and there's a NOAA forecast. It looks like it is consistent with the forecast. Next to layer where it's measured the ionosphere, there it is. Our lovely ionosonde, courtesy of the Australian Government Bureau of Meteorology. So there it is, and we will have some low-frequency anomalies there. Certainly looks like it to me. What about you? Let us know in the comments what you think before we show the anomalygram and give it away. So expecting to see a little more red on there than blue. Looks like it's a little bit tending toward low-frequency anomalies there. That's anomaly in megahertz from the 30-day median. Anyway, here's the WAM, the Global Ionosphere Nowcast, or Whole Atmosphere Model. And the last technical stuff we'll show will be the latest high res. There you go. There's some high res for you. Here's what a 50-50 chance of an X-flare type producing sunspot looks like. Sunspot 3723. It's the part of the closest star that we'll be keeping an eye on. And when I say eye on, well, pardon the pun. Anyway, we're out to get this onto your screens. Thanks for tuning into the Smash News Network, least busted name in news. We'll see you next time, and in the meantime, may that solar wind be at your back.